Hello, everyone, and welcome to the LIUniverse. I'm your host, Dr. Charles Liu, and if you have not yet received the memo says, "Call me Chuck." Hello, everybody. It is such a pleasure for us to be here today, as always, with our co-host, Allen Liu. Hey, Allen.
Hello.
Hi.
Hello.
Computed any strange gravitational potentials lately?
So I was watching a YouTube video talking about how to optimize the shape of a planet to maximize its gravity at a single point in space.
Ooh.
So on
And
on,
what
a,
is the
on its
answer?
surface, it's
Uh-huh.
about 92% of the way to being a sphere, but it's a little bit squashed.
Huh. Well, that's something definitely to be looking at because we've been talking of late, of course, regarding
Mhm.
this mini moon that's been circling around our Earth for just a couple of months. So,
Right? Yeah.
gravitational potentials are big on my mind in general, but they're also big in general when we talk about galaxy evolution overall. Like,
Yes.
what are the potential shapes of the dark matter halos and all those other things, and how does it affect star birth and star death and things like that? And we have the absolute perfect person in the world to be talking to us about those and other extremely cool things. Dr. Kelsey Johnson. Kelsey, hello.
Hey, hey. So good to see you.
I know, it's wonderful. Kelsey and I have been friends for a very, very long time. And the main, like, short reason that we're able to have this particular episode is because Kelsey has written an awesome new book. Kelsey, tell us about this book, please. Wave it up for us to see.
Okay, I can wave the
Okay,
book.
yeah, there you
I've got
go.
my copy
Those
right
of you
here.
who
Here's
are
my
on
copy.
YouTube can see. It is called Into the Unknown. Haha, the
I love
quest
it.
to understand the mysteries of the cosmos by
And I
Nice.
Dr.
have to
Kelsey
say,
Johnson.
please do judge a book by the cover. Um, when I got the cover art for this, I think I was actually at an American Astronomical Society meeting,
Mhm.
and I opened the file and I squealed.
Yeah,
So
That's
I'm very
awesome.
excited.
it is a beautiful, beautiful book. And the American Astronomical Society meeting that Kelsey refers to was the last one that she was president of the American Astronomical Society of, just so you all know. Um, Kelsey, like I said, the perfect person in the world. The reason why we have her, aside from the fact that, like I said, we've been friends for literally decades. Oh my gosh, are we decades old now? Oh no. Well, Alan can keep us young. Okay.
Yeah, okay. I'll do
Yes.
my best.
Kelsey has been president of the American Astronomical Society, my professional organization. She has also been president of the Astronomical Society of the Pacific, which is an even older organization, and it is well known as perhaps the leading institution or group of astronomers in the world to promote education and outreach and extending knowledge of the universe to a wide variety of people, not just astronomers and astrophysicists. So I think it's really special to have you here, and thank you. Thank you for the time you're going to be spending with us, and we're going to have a great time today. Thank you.
Oh, I can't think of a better way to spend my day. This is great.
Marvelous.
Nice.
Okay, so let us go right to today's joyfully cool cosmic thing.
All right.
All right, Alan, everything that I thought of which would be cool has been superseded by something really, really cool, and that is the aurora, the solar
Yeah.
max that's been going on right now. Okay, so what's been going on this year is solar max. That a period of time for all of you in the audience who aren't familiar with this term, that every 11 years the sun goes through, roughly 11 years. 11
Mhm.
years, you have an increase of sunspots and then a decrease of sunspots, and then 11 years later, you have that increase again. And we are in that peak of the solar max. The original estimates were that solar max was going to happen like next year, like in sort of early 2025. But it came early and it came powerfully in
Yeah.
2024 in May. In fact, the morning of Mother's Day, as I recall, there
Mhm.
was a massive storm that led to auroras, northern lights being seen all over the northern hemisphere, including temperate areas like New Jersey and Virginia, which we never would ordinarily see in these kinds of solar
Yeah, I
activities.
heard that people had photos of it with their long exposures as far south as like Arizona and like Puerto Rico even.
Right, right. And so that was like once in a lifetime, and people were like, wow, that's so amazing. But apparently, Solar Max was not done because Max gave us another amazing
Mhm.
aurora night on October 10th. You and I saw that. How would you describe that?
I would describe it as an incredible display of color. So I'd seen the one in May, and I saw that, I saw the streaks of bright and dark areas move across the sky, which was very cool in and of itself. But the October 10th one, the trick was that it was so much more vibrant in terms of the reds and the greens and the streaking these bright spikes of light all the way across the sky and these bands and patterns that were moving. So it was all really, really much more incredible. It's the sort of the way like a somewhat slow motion fireworks display.
Oh, fantastic. Kelsey, did you see those, or have you seen other aurora in the past in your experience?
I wasn't able to see the recent ones, and I am like dying with envy of people who got to see them. So I'm hoping that we'll get some more good light shows coming. But I would love to share with you the first time I saw aurora, because
Okay.
I think this is actually really funny because this was from before I was an astronomer. So
Wow.
I was in high school, and I'll let you do the math and figure out what period of solar maxima that might have been.
11 years
And it
ago.
was
11 years ago.
Yeah,
yeah,
yeah, yeah.
it was just a couple of years ago. And I want to be clear, right? I had not even had an astronomy class yet, so I knew
Wow.
nothing about what was going on in the sky. And I grew up in Minnesota, so you'd think that someone
All
who
right.
grew up in Minnesota would have more knowledge of these things than I did. But
Yeah, it's
I
because it's the
lived under
farthest
a rock,
north of the
so
continental 48 states, right?
yeah, yeah. So, but somehow, this knowledge had managed to escape my attention for whatever. I mean, I was a teenager. Come on, cut me some slack, right? I had other interests
Fair.
in the world. And speaking of other interests in the world, so it was like February or something. It was some very cold winter night, and I had been at my boyfriend's house until very late,
Oh.
probably later than I want to admit on a
Ooh.
podcast. And I pulled out of his driveway. It was like 2 a.m, and I
Mm.
turned north, and the sky was covered in, well, what I now know to be aurora, right? But at the
Yeah.
time,
Wow.
I had no idea. It was just
Wow.
these green glowing lights moving around and doing the thing that aurora do, but
Yeah.
I didn't know what they were.
Wow.
And so I think that, and so for me, this was where something called availability bias like
Oh.
kicks in,
All
Uh-huh.
because
right.
the only solutions I could think of at the time were A, God,
Okay.
or B, aliens.
Wow.
And so I turned on my radio in the car thinking that surely there were going to be like announcements and news stories about like alien invasions or the second coming of Christ, or I didn't know what. And there was
Wow.
nothing. They were just playing like the music of the day, and I'm not even going to give you the decade. And
That's amazing.
and I was like, what is going on? And it wasn't until the next morning, it was Sunday morning, and we got the Sunday paper, and there was a big, above the fold feature on the Northern Lights that I was like,
Wow.
oh. Anyway, um
You felt much better, right?
I felt much better, but
That other
I
people
love
knew how
sharing the
crazy it was.
story
Yeah.
because I love thinking about how people who may not have had an astronomy class or a science class, whatever
Mhm.
area, might interpret things that they see, and I get it because I've been there,
Yeah.
Yeah, for sure.
and it was very cool.
Oh, I can only imagine how cool it was when you see it for the first time and you don't even know what it is. That must
Mhm.
have just been
Yeah, you
so
just
fun.
imagine, like the historical people in Scandinavia or Greenland or, Arctic Canada or whatever. This is just part of their life. And they're like, yeah,
Yeah.
every so often the sky turns weird colors. We don't know
Right?
why.
Yeah.
Well, there was the Rainbow Bridge to Asgard, right? And
Yeah.
Thor was there, and Heimdall was the. Well, anyway, we love that kind of fun discussions too on this show. But let's go to that book, The Into the Unknown, because
Let's
I
do
will
it.
Yeah.
say this: it seems obvious that that experience when you were younger and you didn't know what it was a huge impact on your life. And now
Mhm.
you're thinking all about things that are not known, right? As a world class scientist, you are still
Mhm.
wondering about the things that we don't know or maybe cannot know, right? How does that fit in?
As long as I can remember, I mean, literally back to the time when I was a kid, I have desperately wanted to know what my place in the universe is. Not to
Hmm.
make the universe all about me, and I don't think I'm the only one who thinks this,
Oh, for
right?
Yeah.
sure. Yeah.
And so I think it's actually kind of normal for human. I tell myself it's normal for human nature. Maybe it's not, and I'm just a freak, but that's okay. I want to, I'm going to lean into it. And I, my whole life, I've wanted to know these big, huge existential questions.
Yeah.
And I think when you're like a young adult, I don't know how many people have had the experience of hanging out late at night with friends and talking about these big existential questions. But somehow when you become, Chuck, I'm going to look at you here. Somehow when you become like a full-fledged, like grown up like us, somehow we stop talking about them, right? Like when was
Mm,
the last
mm.
time you sat down with, you know, a fully middle, sorry, my cat's trying to jump on my lap. If I
Oh
look
no, let the
distracted, it's
cat jump
because
on the
I
lap.
am.
It's fine.
Um,
Let the cat jump. Yes.
let the cat jump. Well, no,
Let the
what will
cat
happen
jump.
is she'll try to jump and then she'll get her claws in my legs and then she'll
Oh.
fall and then I'll scream and then your lovely editors are going to have to take it all up. So, um, but seriously though, Chuck, like, Alan, you might still, I have no idea how old you are and you don't need to
Mhm.
tell me, but
Okay.
you might still be young enough that's like cool to talk about existential things with your friends. But somehow,
Mhm.
at
Mm.
some point during our careers, and Chuck, I would love to know what your experience has been. It becomes kind of
Sure.
not okay. It's like not normal for us to
Yeah.
talk about these big existential issues with our
Yeah.
colleagues. And
Yeah.
I think that's really a pity.
Yeah.
And what do
Mm.
Yeah.
you think?
I have always defied that expectation. In
Of
fact, to the
course you
point
have.
where, well, I don't know how successful it's been, but to the point where friends will sometimes tell me, "Boy, that was deep." Right? And I was like, "No, this is no deeper than the stuff that I was spouting with zero knowledge background back when I was a dozen years old or something." Right?
Yeah.
But now that I'm the ripe old age of 23, I have much
Mm.
more understanding, and therefore we should talk about it with more
What
scientific
base are
background,
we
right?
in when you say you're age 23?
Shh.
Yeah.
Sorry, that was a math joke.
The No,
Apologies.
not at all. No, in
Except
on
I'm a
this
nerd, so just deal.
A lot of
on
our
this,
LIUniverse fans are, and if
yeah,
you are, that's great. If you're not, well, glad you're watching anyway.
right. The whole point of this show is to just enjoy and nerd out and geek out. We are not
We
afraid
are
of
nerding
people
out.
being, yeah, not afraid of people being overly or underly nerdy because we're just as nerdy as we all are, and that's how it goes.
Underly nerdy. Okay, I do love that. That's
Yeah.
fantastic.
Yeah, no,
But
that's wonderful.
seriously, when it comes to
Yeah.
these mysteries, right? What I wanted to do with this book is just pull back the curtain and
Hmm.
say
Hmm.
Mm.
and invite people who, apparently, Chuck, this does not apply to you, but invite people who may be hesitant for whatever reason to
Mm.
come into this space and to allow themselves to think about these things. And I
Hmm.
really wanted to create something to invite people into this, to sit with this existential curiosity about
Right.
really big questions and possibly unsolvable questions, at least
That's
in the
right.
near term. And what does that mean for science, and what does it mean for us, as humans,
Hmm.
and how do we go forward from there? So
Right.
this book for me really was a what there's a phrase for this, not a labor of love, passion project, that's the word.
Ah.
Yeah.
Yeah. No, I think that's really great. And one of the ways that I do get around an audience that I'm speaking with feeling too inhibited by experience or many years of whatever being beaten out of you, wonder is I do it with my students
Yeah,
Mm.
because the students they're still very very open to thinking deep thoughts and not at all self-conscious
exactly.
or presumptuous about what they cannot imagine, right?
Yeah.
I mean, one of the things that you've done, Kelsey, in this book is actually done that. In addition to going deeply into certain topics, you also step back often at the ends of chapters and say, okay everybody, for those of you who are thinking, how does this make you think? What is this giving you that makes you want to explore more. And I
Mhm.
think that's a really nice way to reach folks and to find stuff. You've done this in your professional life too, right? Not only have you written serious and deep books and research papers about galaxy evolution, about formation of star clusters and things like that, which has been amazing stuff, by the way. You guys should all read the Astrophysical Journal and the Astronomical Journal, otherwise known as the funny papers, for the kind of work that Kelsey has done for many years. It's very similar. Well, I won't say it's very similar, but it's very closely related to the stuff that I do about galaxy evolution.
It's
Um,
excellent bedtime reading.
it's wonderful. Yes. If you have any insomnia at all, it works very well to read my papers. So what,
I was talking
how
about
do,
my papers. Let's just be clear. Not your
oh,
papers, my papers.
your papers keep me up at night, literally. I go,
Oh boy.
oh no, Kelsey found something. She's right. What do I do? It's marvelous. I love that stuff. But yeah, how have you meshed that deep stuff like Into the Unknown and your research
Mm.
work, along with your you're reaching out to younger audiences or newer audiences. People are just learning stuff. I mean, I'll bet you have another book nearby that you wrote, for kids only, and that's not the only one that you've done, in order to trying to reach out to the public as well, right?
Hmm.
Uh-huh.
Oh, I mean, this is a great question, but for me, they're all just different sides of the same coin. Wait, coins only have two sides. We need something that has more than two
A
sides.
dice, maybe?
Dice.
Same
Well,
size of the same D20. Yeah, there you go.
yeah, oh, there we go. Calabi-Yau manifold. Let's pull that one out, and then
Ooh.
we're
Ooh,
safe.
ooh, ooh, ooh. You have to stop there for just a second, because you may not know this, but Alan is actually a mathematician by training.
Yeah.
So,
Yes.
so please tell everybody what a Calabi-Yau manifold is roughly, and then we'll let Kelsey continue.
Ooh, I don't remember which one's the Calabi-Yau manifold compared to all the other
Oh
manifolds right
no!
now.
Oh no! I've
So
busted you. I'm so
No,
sorry.
that's fine. I'm always excited to find it. Yes, manifolds in general talk about the way spaces can be connected in these abstract sort of shapes, and how you can come up with sort of ways where like sort of the difference between something like a flat sheet versus like a donut shape.
Yes, and there is the picture. For those of you who are
That's a really really knotted up.
for
folded
those
up
of you who are not
crunchy thing.
able to see, if you're just on the audio, Kelsey, just hold up a page.
You'll
What
just
page
have to
number is
buy the
that?
book.
Yeah, what
This
page number
is
is that?
page 250. It's a nice even number.
Page 250.
Yeah.
Yes. And it kind of shows an example of a Calabi-Yau manifold. Manifold being the weird shape thing. Calabi and Yau were two mathematicians / scientists who came up with a way to describe space and time being tangled and twisted in some funny ways.
So yeah, I just looked up on the Wolfram type stuff. So the Calabi-Yau manifold specifically is 6-dimensional. So it's
Oh.
a particular way of describing the extra dimensions in string theory.
Oh.
But you
And
know
so
what's
how those
really
guys
cool about
connect.
those
Yeah.
6 dimensions that I think is I love. All right, I just have to put it out there. And Alan, you're a math
Yeah.
nerd, so I don't know how you feel about this. But those 6 dimensions of the Calabi-Yau manifold, it's 3 dimensions of space, or 3 spatial dimensions. Let's phrase it that way. That would be more appropriate. But they're complex. And because
Ooh.
complex numbers are 2-dimensional, you end up with 6 dimensions.
Oh.
And I just have to
That's
say,
pretty
I want to
awesome.
nerd out about imaginary numbers a little bit, because I feel
Yeah.
like when we learn them in grade school, sorry, I realized, Chuck, we didn't answer your question. We can come back to that, but now I'm gone down a rabbit
Doesn't
trail.
matter. Go for
That's
it. Go
great.
for it.
I
Imaginary
mean, but
numbers are
it was a
freaking
really
awesome.
important question, so I haven't forgotten it, and I do want to talk about how you can have different sides of the Calabi-Yau manifold.
Yeah.
We could say we have different sides of a Mobius strip, but that would be funny because that's a joke.
Because it's only one side
Or
of
a
a
Klein
Mobius.
bottle, yeah.
Yeah, or a Klein bottle. That would be great. I love the nerd joke. Wow, you guys are the best nerding out friends ever.
That's great.
Yay!
Happy to be that.
But imaginary numbers, right? Like, people learn about imaginary
Yeah.
numbers in what, like, I don't know, grade school, middle school, and it's sort of square root of a negative number, and it's kind of left at that as like a nifty math trick that we use. But
Yeah.
I don't think normal people in normal schools who aren't math majors really think about what it means that we have imaginary numbers. And I actually feel like they're really profound. And it's easy to
Seriously,
think they're
yeah.
just like this nifty math trick that we use, but they keep showing up in fundamental physics over and
Yeah.
over and over and over and over. And they're fundamentally 2-dimensional, right? So I don't think we can just sweep them under the rug as a nifty math trick. And so every
Yeah.
time I see them, whether it's like Euler's equation, we should definitely nerd out about Euler's equation.
Yeah.
Or we think about wave functions or whatever it is, they just keep showing up. I think it's like the universe raising its hand and saying, hey, something weird is happening here.
Yeah. So they're 2-dimensional in the sense that, like, you have, when you sort of plot them on a graph, normally you talk about a number line, right? You have numbers that are bigger numbers on one side and smaller numbers on the other side. But with imaginary numbers and complex numbers, you sort of make this 2D grid. So you have the imaginary axis and the real axis. So over here you have like 1 plus I, and somewhere over here you have like 3I plus 4, and that's somehow the same distance from 0 as regular 5 or negative 5, but it's off in a weird direction.
Wow.
It's pretty
So
awesome
much
stuff. And imaginary numbers and complex numbers, like, they make the fundamental theorem of algebra work about the roots of polynomials. They make things about like
Whoa.
electrical engineers use them all the time to talk about impedance versus resistance. It's like there's all this really incredible stuff that they do.
Ooh, oh my gosh, you're bringing back my freshman physics, right?
Yeah.
The impedance, folks, is what happens when you're trying to resist electrical current flow in an alternating circuit current, like the kind that powers our
Power
lights.
lines. Yeah.
Yeah. And whereas resistance is what blocks or impedes flow of electricity in a direct circuit current, like the kind that might be in your cell phone powered by a battery.
Yeah, and that difference can be described by imaginary numbers, and that's pretty awesome.
This is getting too much fun. Okay, we want to keep following these as far as they go because they're so much fun to talk about. But let's go to one of the questions. Okay, let's go to a question.
Okay.
Do we have Alan? Do we have like an astronomy question that we can ask Kelsey?
We do, yeah. So we're going to start with this question from Johnny, who is asking about a fun type of galaxy with a fun name here. What is a flocculent galaxy, and why are they interesting?
Flocculent galaxy.
A great name. I just feel like
Seriously,
you need to say that.
If this were smell-o-vision, I would just be thinking, what is a flocculent galaxy? And you have to just like inject some sort of odor into the air. But that might be a little bit too
I want to
weird.
know what that odor would smell like. But
Indeed. But
Yeah.
flocculent, yes, Flocculent.
Okay,
What is a
your spelling is
flocculent
probably
galaxy?
better than mine. I think I
Okay.
probably like forget a C or something. Flocculent galaxies are, well, one, and maybe this, this may or may not be the most important thing about them. They are really stunningly beautiful. So if you,
Hmm.
presumably anyone watching this or listening to this right now probably has access to the internet,
Yeah.
or they wouldn't be watching or listening. So just like do a quick Google search on a flocculent galaxy and grab a picture of one so you can see like how beautiful they are.
Oh, yeah.
But the other thing you'll
Wow.
notice if you pull up a picture of a flocculent galaxy is they're really like they're kind of just floofy and like chaotic. And so these are totally technical terms, right? But
Yeah,
so
yeah,
they are a
Floofy.
kind of spiral galaxy, like our own Milky Way is a spiral galaxy. But what's different about flocculent galaxies is that even though they are technically spiral galaxies, the spiral arms in them just aren't very strong and they're not very pronounced.
Okay.
And so they just behave in like weird ways. And their star formation, so in a normal spiral galaxy, you see star formation that's associated with the spiral arms because they kind of sweep up gas and material and all the good stuff you need to make stars as they, as they go around a galaxy. But in a flocculent galaxy, you don't have that. And so the star formation in flocculent galaxies is just different.
That's pretty cool.
And also very cool. Yeah. Flocculent galaxies are really
So,
neat.
like, the fluid dynamics of your galaxy can determine what stars are going to form where.
In principle, yeah.
That's pretty awesome.
Yeah.
Yeah.
Well, Chuck,
Now-
this is your line of work too.
Well, to some extent, although flocculence is not something that, well, I might produce flocculence when I'm not careful, but flocculence is not something that I know in specific. As far as fluid dynamics or the motions of gas, oh yeah, it's all about gas, everybody. Flocculent galaxies, gas distributions, and so forth. It's about what happens when gas flows at galaxies that are colliding and merging, right? Because that area I've been trying to think about for a very long time about whether or not you form more stars for a longer period of time or burst them for a short period of time and then stop, and the quenching galaxies dynamics and so forth are important. Now, your work, Kelsey, has to do with the star formation in such galaxies, right? When they're coming together and they're forming not just individual stars, but entire clusters and groups. Give us a sense of how that works and how the state of the art is revealing how that works.
Well, first, I want to take a step back here, though, and I want to
Sure.
do my level best to convince whoever is foolhardy enough to be watching this that star formation is like really important. Like, I think lots of other things in the universe, like they're like flashier or like they get, more news coverage, like black holes, or, it's not
Mm,
that black holes
mm.
aren't cool, right? Black holes are cool. We all know
Yeah,
black holes are cool.
they're cool. They're cool.
But star formation is like the workhorse of the universe. And
Mhm.
almost the entire visible universe that we have access to is through star formation. So star formation and the impacts of star formation are like super fundamentally important. So I just have to put that out there, that this isn't just like some esoteric thing that some random person studies. Like this is actually like really matters. Like it matters enough that we get grants to do it, right?
Yeah,
Yeah.
yeah.
So
People let us use the giant
we've
telescopes. Or you guys use the giant telescopes. They don't let me use the giant
A
telescopes.
star is born. Well, that's also big media, but that's Lady Gaga, right?
Oh,
That's a
that's
different
true.
thing.
That's true. Oh, do you think Lady Gaga would sponsor us?
Ooh.
Ooh.
I don't know. Maybe someone will point out this podcast to her. Oh, that would be really cool. Then maybe she'd endorse my book. Now I'm sorry. Now my brain is
Ooh.
totally going down a rabbit
No,
hole.
this is very, very good. Yeah, no, star
No, but let's
formation.
talk about star
We wouldn't be here
clusters.
without it. Yeah, we wouldn't be here without it.
Okay, so let me tell you about my very, very favorite kind of star cluster.
Yeah.
And I mean, okay, all star clusters are great and right, and no parent loves their children differently. But I do have, all right, I have 3 kids, so I have to be really careful. Right? Okay, but I do have a favorite kind of star cluster, and let me tell you
Okay.
why. And maybe some of your listeners or viewers have seen these because they are perennial favorites. If you have like even for amateur astronomers or a
Yeah.
backyard telescope, you can see these. So in the halo of our galaxy and around every other nearby galaxy that we can see, we have these special kinds of clusters called globular clusters, which
Mhm.
okay, is kind of
Yeah.
a stupid name, right? But
No,
it
no.
is
It's
what
at
it is.
least
They're
as smart as
round.
flocculent. Okay, I think
Okay,
a
fair.
flocculent. No.
Okay,
All
so I'm
right.
envisioning like rock, paper, scissors between a globular cluster and a flocculent galaxy, and I don't know what the third thing would be, but okay, but these globular clusters, all right, the first thing you need to know about them, I mean, I know you know this, Chuck, but I mean, okay, but who knows who's listening? Hopefully not a globular cluster expert because they're going to be really mad at us right now. But okay, the first thing you need to know about them is that these globular clusters that live, we have like 150 of them or so living around our galaxy. They are almost as old as the universe itself, right? They're like
Mm.
over 10 billion years old.
Mhm.
And okay, to state the obvious, that's pretty old.
Yeah.
And to state the next thing that comes from that line of thought is that what that means is that these globular clusters are like fossil records of what was happening in the universe at the same time that galaxies were coming together and assembling for the first time.
Mhm.
So one of the things I love to study in my research is trying to figure out how these clusters were formed, because that gives us insight into what the conditions were like in these galaxies in the very, very early universe that we
Right.
can't actually observe with telescopes.
That's
But the
awesome.
problem is that they were formed. It is awesome, but they were formed so many billions of years ago. You can't really study the formation of new globular clusters, can you?
Well, that's a good leading question.
Shh, shh. Just go with it. Go with it.
People might think we planned this. Although if you can't tell that this is heavily scripted and we're not making anything up as we go. No, so what's really cool is that occasionally in the universe today, we think, and all the evidence we have suggests this, that you can still make globular clusters just very, very rarely because they're really hard to make. And so to make them, and Chuck, this is an area you and I both love. One of the best ways to make them is to slam 2 galaxies together.
Oh yeah.
Yeah, it's galaxy fight. So we can occasionally still try to see them forming in the pretty nearby universe, but they're rare. And the stages that, the lifetimes it takes to form them. Okay, I realize these lifetimes sound long for like humans, right? But hopefully people who listen to this podcast are used to long times, right? They're only forming for like 1 million years, which is like nothing
Oh wow,
in the
yeah.
scheme of astronomy. So they're hard to catch, and they're hard to catch in that stage, but they're very, very cool. And they are the most intense mode of star formation we know of in the universe.
That's great. So if as predicted, Andromeda and the Milky Way collide in a few billion years from now, are we going to get new globular clusters, or are we not correctly positioned for that?
I think we probably will. And I would look. Do you want? I mean, we can nerd out on the physics here if you want. I don't know how deeply we want to go into the nerding of the physics, but what
Worst case, we
happens?
make it a Patreon extra.
We look to the editors to figure out
That's right.
how to fix this going too far down this rabbit trail. Yeah. So the galaxies have all of this gas and dust, and when they smash together, that gas and dust loses its momentum, and it
Mm,
tends to well, one, you have really intense shocks as they slam together,
okay.
but then you also, as it loses its momentum, it funnels down into whatever the local gravitational potential is. And so you
Mm.
can collect a lot of it really fast under really high pressures and really high densities and get some spectacular star formation.
Oh,
Mm.
okay. And
And
that's
that's where you would wind up creating thousands of stars within a million years, or millions of stars within a million years. And that would be the core of your new globular clusters. Wow.
Yep, that's right.
I
that's
would love
pretty
to see
awesome.
them. Yeah, there's some really wonderful stuff. Hi, everyone. I hope you enjoyed part 1 of this LIUniverse conversation. Please join us for part 2, coming soon to these same channels. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.